Welcome to this explainer. Okay, so we're unpacking something truly phenomenal today. You might think the ground beneath your feet is completely static, right? Well, think again. We're going to look at the invisible, colossal geological forces that literally sculpt our planet and, honestly, dictate human survival in so many ways. Every single mountain you see, every valley you drive through, and every earthquake we feel is just part of this massive, ongoing story of creation and destruction. And today we're going to read that story together. So here is our game plan for today. We're going to cover four main areas. First, the engine within. Second, breaking and moving. Third, sculptures of the earth. And finally, when nature strikes. All right, let's dive into part one, the engine within, focusing on deep earth dynamics. Just take a look at this breakdown. The crust, the part where we build our entire civilization, makes up just 24% of the planet's layers. To put that into perspective, it's kind of like the skin of an apple. It rests directly above this massive, hot, shifting mantle. And beneath that, an incredibly dense, extraordinarily hot core. To really understand the surface, you have to understand that we are basically riding on top of a giant, heated planetary engine. And that fiery engine brings us to a massive, absolute game-changer in Earth science, plate tectonics. Proposed by W.J. Morgan, this theory explains that our outermost layer, the lithosphere, isn't just one solid shell. Actually, it's shattered into these massive puzzle pieces called tectonic plates. Because of the intense heat radiating from the core, convection currents churn in the semi-molten mantle below. These currents, slowly but with absolutely unimaginable force, push and pull these huge rock slabs across the globe. And get this, here's a fun fact for you. These massive plates are crashing and pulling apart at roughly the exact same speed that your fingernails grow. Now, what's really interesting about this is how these plates interact at their edges. These boundaries create our world's most dramatic geological features. When plates crash into each other at convergent boundaries, the Earth literally buckles, pushing up towering fold mountains like the Himalayas, or sparking violent volcanoes. When they pull apart at divergent boundaries, magma rises up from the depths to create brand new crust, like the sprawling Mid-Atlantic Ridge. And when they grind past each other at transform boundaries, well, they create massive fault lines like the San Andreas Fault, which are notorious for triggering immense earthquakes. But long before we had modern tectonic theory, ancient scholars were actually observing these terrifying phenomena. Take ancient India, for example. The scholar Varahamihir dedicated an entire section of his text, the Brihat Samhita, to earthquakes. He brilliantly blended early observation with cosmological reasoning, attributing those massive tremors to four elemental forces: wind, fire, thunder, and water. It really shows us that for thousands of years, humanity has been desperately trying to make sense of the awe-inspiring power rumbling right beneath our feet. Okay, let's move to our second section and see how this builds. Breaking and moving, the breakdown. So, the crucial point here is the hard line between two processes we constantly mix up: weathering and erosion. Weathering is simply the breaking down of rocks in place. This could be freezing temperatures, cracking a massive boulder, or even tiny planet roots splitting a stone over decades. The key here? Nothing moves. Erosion, on the other hand, is the actual transportation of that broken material. When wind, water, or ice takes those broken pieces and carries them miles away, that is erosion. It's this relentless 1-2 punch that can completely level mountains and reshape our landscapes over millions of years. Right, moving into section 3, sculptors of the earth, the agents of gradation. I want you to think of a river as having an actual lifespan. In its rebellious youth, the upper course, it violently carves through mountains, creating steep V-shaped valleys and super dramatic waterfalls. As it reaches its middle course, it starts to lose some of that explosive energy, slowing down to create wide, winding meanders. And finally, in its old age, the lower course, it slows to an absolute crawl, dropping all the sediment it's carried to form massive, highly fertile deltas right where it meets the sea. But water isn't just busy in the mountains. It's also constantly bashing against the coasts. The relentless, hammering action of oceanic waves acts as a powerful sculptor. Over time, waves undercut coastal rock to create steep sea cliffs. They hollow out weak rock to form sea caves, which eventually break right through to become stunning sea arches. And when those arches collapse, they leave behind towering, isolated rock pillars known as stacks. Oh, and all the sand from this destruction, it gets deposited to create the beaches we love. So every time you lay on the sand, you're literally resting on the pulverized remains of ancient coastal rocks. Now, imagine that same river, but made entirely of solid ice. Glaciers act like these giant, slow-moving natural bulldozers. As they slowly grind over the land, they scrape out the old V-shaped river valleys, widening them into massive U-shaped valleys. When these incredible valleys meet the sea and flood, they create breathtaking fjords. And as glaciers eventually melt and retreat, they don't just disappear into thin air. They dump huge, winding piles of rocks, soil, and debris known as moraines. So what happens in areas where water and ice are scarce? Well, wind becomes the master sculptor. In arid and desert regions, the wind acts like a natural sandblaster. It aggressively polishes rocks into smooth gems called ventifacts, and it carves long, streamlined rock ridges known as yardangs. The wind also gathers all that loose sand and piles it up into massive, shifting dunes. A perfect example is the iconic crescent-shaped Barchan dune, which actively migrates and acts as a dynamic natural barrier across the desert floor. Our final sculptor operates entirely out of sight: underground water. When rainwater mixes with carbon dioxide in the soil, it actually becomes slightly acidic. As this acidic groundwater seeps through soluble rocks, like limestone, it literally eats away the rock from the inside out. This chemical weathering hollows out massive, intricate cave networks. Inside these caves, mineral-rich drips create hanging stalactites. Remember, they hold tight to the ceiling. And rising stalagmites, which might reach the top. And when the roof of one of these underground cavities can't support itself anymore, it collapses, creating sudden dramatic sinkholes right on the surface. This brings us to our final section: when nature strikes, the human connection and disasters. And this brilliantly illustrates how human survival has literally always depended on mastering these forces. Look at the ancient Sindhu-Saraswati civilization. They didn't just passively exist on the land, they actively manipulated these geological realities. By employing highly advanced, well-documented techniques like terracing, dams, and canals, they managed water flow, prevented massive erosion, and thrived in a really dynamic environment. They intimately understood the landscape and engineered ways to work alongside it. But when the delicate balance of these landforms is disturbed, things go south really fast. Take landslides, for instance. They occur when the materials on a slope finally give way to gravity. This can be triggered by purely natural events like an earthquake shaking the ground or heavy continuous rainfall making the soil way too heavy and slick. However, humanity often tips the scales. When we cut down the forests that naturally anchor the soil with their roots, or when we build roads with poor drainage, we drastically increase the instability of these slopes, leading to deadly, catastrophic failures. And high up in the mountains, a very similar threat exists with avalanches. But instead of earth and rock, we're talking about massive layers of snow that suddenly become unstable. This can happen because a sudden, heavy snowfall adds too much weight too quickly to a steep slope. But it can also be triggered by a sudden temperature rise that partially melts the snow, destroying its friction, or even by minor vibrations from an earthquake or human activities like skiing. When that fragile layer finally breaks, thousands of tons of snow collapse violently down the mountainside in just seconds. There's another mountain hazard that is becoming incredibly critical right now: glacial lake outburst floods, or GLOFs. As global temperatures rise at unprecedented rates, glaciers are melting rapidly, overfilling glacial lakes. These lakes are usually held back by natural dams made of ice or those loose rock moraines we talked about earlier. When heavy rains, an earthquake, or just sheer water pressure causes one of these fragile natural dams to burst, it releases a catastrophic wall of water and debris downstream. This terrifying chain reaction was exactly what caused the devastating flood in the Chamoli district back in 2021. Down in arid regions, the disaster actually comes from the sky. Dust storms happen when strong winds rip across exposed, dry soil, lifting massive amounts of blinding sand and dirt high into the air. While totally natural to dry regions, they are heavily worsened by prolonged droughts and human activities that strip the land of vegetation, like deforestation and overgrazing. Without plant roots to hold the topsoil down, the wind easily whips it into massive, suffocating clouds that destroy crops and completely halt transportation. So, from the immense, slow-motion crashing of tectonic plates deep within the Earth's core to the intricate carving of rivers, wind, and ice up here on the surface, our planet is anything but static. Every physical feature you interact with is just a temporary monument in a constant, endless cycle of creation and destruction. We've seen how deeply our survival is tied to these processes, both as life-giving resources and as devastating hazards. The surface beneath your feet is literally moving right now. So, knowing what you now know about the raw, unstoppable power shaping our planet, how will it reshape your world tomorrow?